this lesson, we'll continue adding components to the reducer. We'll add the driven shaft, the oil-retaining rings, the bearings, and the covers. We'll modify the components to match each other using both the solid modeling and direct editing tools. Let's get started. Add the driven shaft into the assembly. Start the Add a Component from a File command. Select the driven shaft. Select the by matings placement method. Make the ZY planes coincide. Then apply the coaxial mating to the cylindrical faces. Select the XY plane of the worm wheel and the XY plane of the driven shaft. Click Parallel. The key seat and the keyway should match. Confirm. Then let's add 2 oil-retaining rings. In the Parameters panel, select the version and variant. Click By Matings. Turn off the section mode. Hide the cover. Select the flat face of the ring and the internal flat face of the housing. Apply the coincidence mating to them. Apply the coaxial mating to the cylindrical faces. Confirm the first ring insertion. Insert the second ring on the opposite side in the same way. Add 2 bearings with the inner diameter of 85 mm. Use the coincidence and coaxial matings to position the bearings. Then add the cover. Apply coincidence. And coaxial. Note that the holes in the end cover and the housing don't match, so we need to modify these components. First, we'll fully define the end cover position. Find the end cover in the tree and start the Place Component command in the context menu. Make the ZX planes of the reducer assembly and the end cover parallel. Confirm. Select the housing in the tree and start the Edit Component in Place command. Hide the end cover. Create a new sketch. We'll project the cover whole edge onto it. Unhide the cover. Start the Project Object command. Select the whole edge. Exit Sketch mode and the Editing mode. Agree to save. Start editing the housing in a separate window. Let's edit the sketch that was created in the assembly context. Change the line style for the circle to dashed. Create a circle with the center at the origin. Change its line style to centerline. Start the Point on Curve command. Select the new circle and the center of the projected circle. Start the Points on Curve command. Select the circle and its lowest point to place 4 points uniformly along the circle. Change the number to 6. Confirm. Delete the upper points. Exit Sketch mode. Start the Delete Faces command. Select the faces of the holes in the housing to delete them. Don't forget the other side. Start the Hole with Countersink command. Select the sketch point and the housing's flat face. Turn on the thread. Change the standard if you need. The thread length will be the entire hole length. Set the hole depth to 18. Set the countersink method by depth and angle. The depth will be 0.5. Confirm the hole creation. Start the Array by Points command. Select the hole if it's not selected. Activate the Points field and select the sketch with the points. Confirm. Add the same holes to the opposite side using the Mirrored Array command. Select the ZY plane as the symmetry plane. Confirm. Save the housing document and close it. Return to the reducer assembly. Select the end cover in the tree. Open the Children folder in the Additional window. Select the parallel mating that restricts the cover's rotation around its axis. Apply the coaxial mating to the holes of the cover and housing. Create the same holes in the cover in the same way. If you encounter some problems, you can find the result file on the course page. We also need to place the cover on the opposite side of the reducer. Add the open end cover. Place it using the following matings. Coaxial for the center hole, and one more coaxial for the holes with the countersink. Coincident for the flat faces. Finally, add the inspection window cover to the assembly. Make the flat faces coincide. Make the holes concentric. Save the reducer.